In this video, I'm going to talk about how to sketch a function from the given information, and there will be one like this on the exam. So in these problems, they are going to give you different information about the graph, and you are going to use that to sketch it. So the first thing I would start with is any points they give you on the graph. So in this one, they say f of 3 equals 0. So remember, this is my x value, this is my y value. And this is only the case if it says f. If it has the prime or the double prime on it, then it is not the y value. It's like the slope is the first derivative, or the second derivative gives you the concavity. So the only points that we plot are the ones where it's f of something equals a number. So I'm going to plot when x is 3, y is 0. So a point here. When when x is 0, y is 5. And when x is -3, y is -2. So those are 3 points I definitely know, and my graph has to go through, but I don't want to just connect them because I don't know what it looks like otherwise. So the other information is going to help me know, where is my graph decreasing or increasing? Where does it change concavity? So they said f prime of 3 equals 0, f prime of 0 equals 0, and f prime of -3 equals 0. So generally when the derivative is equal to 0, it means that there is a max or a min there. There's one other type called a plateau point, but we won't really do those. So anytime the derivative equals 0, it should be a max or a min for this course. Then we have the second derivative equal 0 at -2 and 2. And this is going to tell us most likely points of inflection if the concavity changes. So we need to focus on this part here to figure out about the first derivative, to figure out if 3 is a max or a min, if 0 is a max or a min, and -3 is a max or a min. And what I recommend doing is a sign chart, one for the first derivative and one for the second derivative, to help you with the concavity as well as where it's increasing or decreasing. So you want to base the first derivative on where the derivative is 0. So I have 3 x values. I have x is 3, x is 0, and x is -3. And I'm going to do them from left to right. They don't have to be perfectly spaced like it would be on a number line. You just need those on here. And then I'm going to put 0 for the derivative for all of those because that's equal. And then they should tell you about if the derivative is positive or negative on each of these intervals. So it says f prime of x is greater than 0. So the first derivative is positive when we're between -3 and 0. So between -3 and 0, I'm going to put a plus sign to indicate it's positive, and from 3 to infinity. So from 3 and greater, I'm going to put a plus sign. Then it said it's less than 0, the first derivative, from -infinity to -3. So it's when it's less than -3 over here, and from 0 to 3. So I'm going to put a minus there. So what that means is if the first derivative is negative, the original function is decreasing. If it's positive, it's increasing. Negative, decreasing. Positive, it's increasing. And this can help you figure out if these are mins or max. So you can kind of see it here, but if my graph decreases and then changes to increasing, that point where it changes has to be the lowest point, which makes it the min. And the opposite, if my graph is increasing or going up and then starts going down, the point at which it changes, where the slope would be 0, has to be a max. So this would be a max. And again, if it changes from decreasing to increasing, you have a min. And before I graph it, I have to know concavity. So don't jump into graphing this. Make sure you also figure out where it changes concavity. So my inflection points are most likely at -2 and 2. So I'm going to put those on my second derivative. number line. And then I'm going to just focus on the second derivative. So from negative infinity to -2, the second derivative is positive. From 2 to infinity, the second derivative is positive. And the packet is missing this part. It should say on here that f double prime of x is less than 0 from -2 to 2. And because it's less than 0 from -2 to 2, we're going to put negative here. Now the second derivative tells me concavity. So from negative infinity to -2, because the second derivative is positive, it's concave up. From -2 to 2 is concave down. If the second derivative changes sign, or the function changes concavity, then we have a point of inflection where it changes sign or changes concavity. And same thing here, from 2 to infinity, it's concave up. So at 2, the concavity of f changed. So this is also a point of inflection. So using this information, I am going to sketch a graph of this function. So I need to make sure up until I get to -3, my function is decreasing and concave up. And then at -3, I'm going to start increasing, but I'm not going to change concavity until I get to -2. So it doesn't really matter. They don't give me any other points except these. So it doesn't really matter where you start at your height. You just want to draw it so that it's decreasing until I get to -3 and concave up. So it's curved upwards. And then I want to continue being concave up, but now I want to increase it till I get to 0. Now, when I get to -2, and again, I don't know the y value, so I'm just going to go to -2, I need to change from concave up to concave down. This is sometimes really hard to show. So do your best to show that it changes, but you might want to like mark that it's a point of inflection, PI for point of inflection. And maybe if it's hard to tell on your graph, like make a note for me, like that this should be concave up and here should be concave down, so that I definitely know, because they're not always easy to draw. Okay, so I'm increasing until I get to 0. And then starting at 0, I'm going to decrease, and I'm still concave down until I get to +2, which again, they didn't tell me the y value. So it doesn't really matter where I go. I'm going to go concave down. And then at 2, I'm going to do my best to make it curved up. Again, what I would do at this point is like write PI and then make sure you note like this is concave up, or you could just put up instead of concave so that I know. And at 3, which is where we're at, it is a min. So now I need to start increasing and be concave up the rest of the way. So I just keep going, increasing and concave up. Okay, so do your best to show the change in concavity. If it's not obvious with how you drew it, then note it on your graph and make sure you indicate where the points of inflection are. So that's how I would graph this one. Okay, so let's look at another one. So it says use the information to graph f of x. So the domain is the set of all real numbers except x equals -1. So that means there's not going to be a point when x is -1. We have f of -3 equals 2. So I'm going to plot these. Again, this is my x, this is my y. So at -3, I'm going to plot a +2. At -2, I'm going to plot a +3. At 0, I'm going to plot my y value to be -1. And at 1, when x is 1, my y value is 0. So then I have information about f prime of x. So they said at f prime of x from negative infinity to -1, my first derivative is positive, and also from -1 to infinity, it's still positive. So my function is increasing the whole time. But remember, -1 doesn't exist, which is why it's this point. This point is undefined, is on my number line for f prime. And then it says f double prime of x. Again, it changes at -1. So is greater than 0. So it's positive. So it's concave up from negative infinity to -1. And it's less than 0 from -1 to infinity. So it's concave down. Right. And so again, this point is undefined. So it's not really the point of inflection, but it is where it's going to change. And then they told me there's a vertical asymptote at -1. So I do want to draw that in. A vertical asymptote, we usually put a dotted line for it, and my function cannot cross it. Okay, so this is not in the domain. X never crosses this x value, or my function never crosses that x value. And then a horizontal asymptote at y equals 1. So that would be here. So I'm going to draw a horizontal line at 1. Now, technically, a function can cross a horizontal asymptote just as you go to negative infinity out this way and to positive infinity, it goes along this curve. But you can technically cross a horizontal asymptote, just not as you go to positive and negative infinity. Okay, so then I'm going to write my sign charts up here to help me a little bit better so I don't have to keep scrolling up and down. So this one was positive, positive. Okay, so my function is always increasing. And then they said it was positive and then negative. So it starts concave up and then it's concave down. So I need to draw my function going through these points, increasing and concave up. So I'm going to start at this asymptote really close. And then as I come here and get to these points, I'm going to go through these points and make sure that I'm curved upwards. So this would be my increasing and concave up. And then I need to come, what my function kind of always traces along an asymptote. So the function will get closer and closer to the asymptote, but never cross it. So the same thing here is because it's increasing and it has to go through these points, it would start down here along this asymptote and increase and come up to these points. And then again, I'm curved down because they said concave down. So it looked like this. Just to make sure that you can see what it looks like before I move on. So this is the graph of this function. And we're going to do one more. So we're going to use the first and second derivative plus this other information to graph f of x. So the domain is the set of all reals. So my graph is going to hit every x value. The limit as x approaches negative infinity is -3. So what I do for this is just like as I go to the left, which here, like out this way, is as I'm going to negative infinity, and this way is as I'm going to positive infinity. I'm going to draw kind of a dotted line that my function's getting close to this value, but it's only the left limit. It's not like the whole way across because it's not a horizontal asymptote. So just keep in mind that my function is going to approach this as I come and get more and more negative for x values. But it really doesn't matter what happens over here. It can definitely cross y equals -3. The same thing as x approaches infinity. So as my x values get larger and larger, my y is going to approach 3. So I'm going to just draw a dotted line to indicate my function has to get close to this y value. I don't know if it's going to start above or below. I need to look at the other information to figure that out. But I know it's going to get closer and closer to this y value as my x values get larger. Okay, these are all points. These are my x value. These are my y values. So those I can plot. Okay, so I have -2 for x, y is 0. -1, 2. So I have -1, y is 2. 0, 0. So it goes through the origin. 1, -2. And then my last point is 2, 0. Okay, so you can get an idea of what it looks like, but we need to pay attention again to concavity, increasing and decreasing. And this time they give me a sign chart. So in this case, I would draw in your F and they give me the second derivative sign chart, and then I would fill that in. So until we get to -1, F prime is positive. So that's saying the slope is positive, which means my function is increasing. From -1 to 0, I am getting that it's decreasing. Okay, so because I'm going to increasing to decreasing, I have a max when x is -1. Remember, these always indicate x values on my sign chart. Then from 0 to 1 again, it's negative, so it's still decreasing. And then from 1 on, it's positive, so it's increasing. So this is a min because my function is going from decreasing to increasing. And then for the second derivative, they told me that, and again, this is f double prime, I'll put it on the side. It's positive, which means my function is concave up. From negative to 0, it's negative, so it's concave down. So this is a point of inflection. It changes concavity. Here I have positive, so it's concave up. And this is also a point of inflection. From 0 to, from 2 to infinity, my function is, my second derivative is negative, so I'm concave down. So this is a point of inflection. Okay, so ND means it's not defined, which means when I took the derivative and I plugged in 0, I got 0 in the denominator. So that point doesn't exist for the derivative. But it does exist on the original function because it is the domain is the set of all real numbers. And it can either be a point of inflection or it can be a max or a min. For a max or min, it's usually called a cusp. If my function changes from increasing to decreasing and it looks like this, it's a really sharp curve. What happens is the derivative there is undefined and they use ND for this notation, not defined. It would look like this. That's not in this case because it stays decreasing. And I don't think it will come up much in this course, but that is one of the types. Okay, so now we're going to do our best to graph it. So my graph from negative infinity to -1 is increasing, and I need to check the concavity. Okay, it's concave up to -2. So that's the first thing I have to pay attention to, and it's increasing. Okay, so I need to be concave up and increasing, and I need to come from this line. Like I'm really close to this line. I need to be above it so that I hit these points. So I'm going to be tracing along this line and I'm going to be curved upward and increasing. And then at -2, it says I have a point of inflection and it's going to be changed to curve downward, but I'm still increasing until I get to -1. So again, these are really hard to show. Let me fix that a little bit. Do your best to show. And again, I would write like this is up, this is down. This is my point of inflection here. And then at -1, I start decreasing. And my next points that I have to pay attention to is 0. So I'm decreasing concave down, but then at 0, I have a point of inflection again, I'm changing to concave up. So I'm going to stay concave down as best that I can, decreasing. And then I'm going to switch it to concave up and stay decreasing until I get to 1. and my concavity stays the same of up. So I'm going to go to 1. Okay, and then at 1, I start increasing. That should be a min. And I'm going to stay concave up until I get to 2. And then at 2, I'm going to change the concave down. So I'm going to go concave up and increasing to 2. And then I'm going to do my best to start my curving downwards. So from here, I'm going to curve down. And then again, I'm going to trace this asymptote. So I'm going to get really close, but not cross it. Now, technically, it would be right. You could also draw your function like going up and then tracing it this way for that. But since they didn't really tell me any other max or min, I don't want to change it to decreasing. So it's safer to just do, I guess I'd have to come up and come back down. So you don't want to do that. Just do it this way along there. Okay. So that's how you graph. Again, I would say here, I would say this is down, just so you can tell here is up, up, down. So either make it really clear, or if it's not clear, then make sure you label where your points of inflection and where it's up and down if it's hard to tell. Okay, like this is a really bad down. That still looks like it's up. So a little bit more. It should be really smooth, but something like that. So the curve should look like this. So again, if you have any questions, let me know.